We may see the convergence of a form of AI and a form of blockchain that enables payment between agents to accomplish exchanges of services, goods, and value in payment.
Should AI agents be interacting with clients for financial firms today? What's your opinion on this?
Well, I think we can use agents for certain application. I don't think we're at the point where we can exchange a meaningful or material value through agents without some form of very serious control, because the risk is just too high.
10,
7, 6,
4, 3, 2.
Welcome to UNAI. I'm your host, Chris Luckenbill, and today I have the pleasure of chatting with Frederic Siboulet. Frederic is a financial veteran who's lived through every hype cycle and emerged with the receipts. After 9 years in investment banking, 6 with JP Morgan, 3 at Citi, Frederic stepped away with a rare perspective. He's seen both the promise and the perils financial innovation bring. But that was just his warm-up act. Today, as a risk advisor at a major U.S. bank, an NYU Tandon adjunct professor, and managing director with the Big Four consulting firms, Frederic brings a trifecta of credentials that's hard to match. MSc, CAIA, CQF, ARPM, AIFI, and RAI certifications. These aren't just alphabet soup. They represent mastery across quantitative finance, alternative investments, and AI implementation at enterprise scale. Frederic has spent years in the trenches where real money meets real models, watching AI systems succeed spectacularly and fail quietly. He's here today to help us understand where Gen AI actually delivers return on investment versus where it's still just an expensive theater. Frederic, welcome to UNAI.
All right, good morning, Chris, and thank you for having me here. Happy to answer all your questions.
Awesome. Frederic, you framed AI as alien intelligence, which borrows from Yuval Harari. What shift in our perspective when we think of AI as alien rather than just artificial?
Well, there is a fundamental difference between our we think and our machine think. They're mostly trained on human knowledge, and they're trained on human algorithm, how to define a problem. And then they follow their own course on models and systems that are very specific to the way they were designed. So there was this moment in 2017 where this company called DeepMind, which was acquired by Google, published a paper called "Attention is All You Need." And that was really, I'd say, the end of what's called the AI winter, where people that thought of giving up on AI. Mm-hmm. So there was already some initiative like in image recognition and a number of things, but Attention is All You Need was really the launch pad for an entire industry. Mm-hmm. And from there, Google and the company they had acquired, DeepMind, ventured on their first really major public initiative, which was to design and operate a system that would be able to win the game of Go against the best players in the world.
Mm-hmm. And working from that deterministic system to this idea of not being deterministic, right? Or
so the idea was it was a quantum leap, basically, from when it happened in 96, 97, when Kasparov, lost the game to Deep Blue. And then there was another 20 years before the game of Go could be won by a machine itself. So that happened when DeepMind and their system AlphaGo won the game against a gentleman called Lee Sedol, who was the Korean champion and arguably the best or one of the best Go player in the world.
Mm-hmm.
The move that AlphaGo made at that particular moment was named the divine move because it was unusual and it was not something that any of the champions had ever seen. So from there on, AlphaGo became more and more powerful. Then later on, DeepMind came up with another game called AlphaZero. AlphaZero could learn and play any board game and win any board game. So not just Go and chess and checkers, but you know, whatever game. So we're starting to see a form of intelligence that goes above and beyond what human can do, and which is becoming extremely powerful, and which is competing with the best minds. So that's why Yuval Noah Harari came up with, or one of the reasons why he came up with this term alien intelligence, because it's it's not the type of intelligence you can see from emerging from humans, from human civilization. It's just something different.
Yeah, so there's two competing forces there, right? That we have this grand, this ability for AI to start to make these big moves and to make big changes that we're taking interest in. But artificial intelligence, the LLMs are giving this illusion of intelligence, and it's creating a human trust problem, right? So where do you think that practitioners, and even experts, like, where are we misunderstanding what these models are actually doing?
Well, this model at the moment, they're not really intelligent per se. At the moment they mostly imitate human behavior or human way of thinking. But at some point you see there are two things we need to consider. The first thing is, what is intelligence? How we define it? How do we measure it? So that's the first set of problems. The second set is, do we consider intelligence as in a specialized field or as in a generalized field?
Right. Yeah.
So maybe if I go to the second question, when I say we do have superintelligence, this superintelligence we have today is specialized. Mm. So AlphaZero can play any board game, can learn and become very effective at learning every board game, but that's the one thing they do. They're still specialized in that particular field. AlphaFold is specialized in protein. Deep Blue was specialized in playing chess, and that goes back, almost 30 years ago now. So in a sense, if we define superintelligence as being smarter than the smartest human in the particular field, like for the game of chess, being able to beat the best chess player in the world, then we had superintelligence in 1997 when Kasparov lost against Deep Blue. Mm-hmm. However, today in 2025, we still don't have general superintelligence. So a superintelligence that can beat humans at any topic.
Right. Yeah, you talk about, you present these 5 levels of generalization, right? And they go from narrow to universal. Where would you place today's most advanced models? And maybe start with, what does the model ecosystem look like? And then where would you place those models in this spectrum of narrow to universal? So
the first is narrow intelligence, which is, the traditional ability to have machine follow a set of instructions in a deterministic way. So that's what I learned when I went to school, computer science school. Understand what needs to be done and code it and have an input, have an output, and the output is completely deterministic. So that's a narrow application of artificial intelligence. Then you have local generalization. So that's the first generation of AI where you see machine learning. So they are not completely deterministic. There is a little bit of stochasticity that is involved. The input may be slightly different because the machine learns from the data. Instead of programming a function what you do is you fit a model, and that fitting is statistical. So there is a little bit of uncertainty around what comes out of it, but it's very local. It's very specialized. So, for example, in finance, you see a lot of that used for portfolio construction, for risk management. These are the typical applications. Then you have the third level, which is broad generalization. So that's a typical example is FSD, full self-driving, or driving a vehicle. So you can teach a car to drive itself, and then that car is going to learn on a limited set of examples. In practice, it's millions of examples. Tesla always talks about the large amount of data they have and the competitive advantage they have in being able to train their self-driving vehicles. But Google with Waymo also has quite a bit of a presence in that space, as well as NVIDIA is getting in that space. So you have a number of startups also. So, but this is a broad generalization. Why? Because the car or the algo, the driving algo, learns on a subset of examples, but then it should be able to drive itself in any road of the world, even if it has never seen the road before. Then you have level 4. So we are level 4. So we are able to generalize and adapt. That's what's characteristic of level 3 and 4. So we can use our experience, or if we don't have any experience, we can use our intuition to produce things that are logical, that make sense, that take us to a certain objective. So the pursuit of objective. And that's level 4. And then we have level 5, which is real universal superintelligence, and we are not there yet. Systems are not there yet, but it's a form of intelligence that we suspect is beyond what we can comprehend. So this model, these 5-level models, was defined by a paper that was published by a researcher at Google, called Francois Chollet. Since then, Francois has created a company called the ARC, and they have sort of a benchmark to measure AGI. So this benchmark has split into 3 now. They have 3 forms. They have the classic one. They have another one, a second level, which measures the intelligence in neural networks. And they came up with a third level, which is a benchmark that measures the intelligence in reinforcement learning. Reinforcement learning being a form of algorithm that pursues objectives and then try to maximize what's called reward over time. So it doesn't think like a neural network. I mean, the algo is different from a neural network. And it's also different from the classic machine learning, which was the original one that they were measuring. So today they have really 3 sort of benchmarks that are there and that measure the performance of those systems.
Yeah, in the ARC AGI and the MMLU benchmarks, what kind of reasoning or intelligence are we still struggling to capture? Like what, and in finance in particular? Okay,
so if we go really into the deeper layer, ARC AGI is not really a benchmark, it's a competition. There is a prize, right? So if you reach a certain level, you can collect money. So it's a bit more like a Kaggle competition, if you want. But you mentioned MMLU. MMLU is really a benchmark. So it's 16,000 questions across 57 topics. It's a multiple choice question. And so it's very easy to rate a system based on MMLU. But MMLU is not the only one. I mean, first they came up with a second, a more advanced version. It's called MMLU Pro. Although I haven't checked recently, but things are moving very fast in that space. So you may have yet another version. So to answer your question, MMLU is a series of multiple choice questions, and you simply rate, the quality of the answer. Now you have Hugging Face, who is open large language model benchmark. You have Humanity Last Exam. So the idea of Humanity Last Exam is to crowdsource the most difficult question and see how these AI system can answer them.
So let's bring this back to ground. Where have you seen AI deliver actual measurable return on investment in finance or even in regulated industries?
Well, I think right now coding is probably one of the space where you have the highest ROI. It's not limited to finance, by the way. It's across industry.
Mm-hmm.
So there was, this big statement by Jensen Huang, the CEO of NVIDIA, which said that, you no longer need to learn how to code. I don't mean to contradict him, but, I think that it helps if you know how to code, because if the AI generate code, if you can code yourself, you can know whether this code is high quality or not. So it's very fast. It's much faster than doing by hand. But it's also very inefficient energetically, right? The human brain uses very little energy to produce 1,000 lines of code compared to an AI system.
Are we in an era where we're developing new capabilities on the buy side, or are we just improving and making human systems more efficient? Not from an
I
energy.
think at this stage, we're at the stage where we're improving machine learning. We are generalizing the use of large language models and generative pre-trained transformers, which was the name that came up when they were released in 2017 with the DeepMind paper. There has been limit on how efficient those GPTs can be. Actually, there was a couple of papers that were published in that space. It was the OpenAI and DeepMind. I published a couple of papers. The first one was a Kaplan paper. It was published in 2020. And essentially what it said is bigger is better. So the more data you have, the more parameters you have, the more accurate or the better prediction your GPT is able to do. And then a couple of years later, I think it was 2022, there was a paper called the Chinchilla paper that said there is really an optimum between the number of parameters of the models of the generative pre-trained transformers and the number of tokens, or the number of words if you prefer. In English, a token is roughly a word. So that there's an optimum between the number of tokens and the number of parameters that the model can sustain. So the optimum is around 20 tokens per parameter. So if you build a bigger model, but if you don't have enough token to train it, then your model becomes undertrained, underfitted. And that creates hallucinations, that creates errors in the inference. So that was 2022. We're now 2025. We have now reasoning model, which are based not just on training. In those systems, you have really two phases, right? You have the training phase where you use a very large corpus of data to train the model. And then you have the inference, meaning you take one particular question, you run it through the model, and you produce an output. And now those so-called test time compute. So those inference in thinking system now, they can do sort of self-criticism. So they can explore multiple answers, multiple outcomes to the same question, and they can figure out which one seems to be the best answer to the question. And that's what's called a reasoning model. This is also very compute intensive at the inference phase, because the first GPTs, once they were trained, you would put the prompt, what's called the prompt, through the system, and it would produce the answer right away. With reasoning model, it takes a lot longer.
So can you give us a little bit of a background on, you talk about these 3 stages of blockchain, and maybe go through 1 and 2 so that we can talk about everybody's favorite topic, which is AI agents, right? And this idea of where do we stand on agent to agent communication. So can you walk us through these sort of 3 evolutionary stages in blockchain?
Bitcoin started really in 2008, shortly after the financial crisis. So in October, that a guy called Satoshi Nakamoto published his paper on Bitcoin. Well, I say a guy, but we don't really know him. He's anonymous. Could be a bunch of people. It could be anyone. So we don't know who he is. But he published his paper, and that was the beginning of Bitcoin. There was this famous transaction where somebody bought a pizza with Bitcoin for thousands of Bitcoin. Convinced the the pizza seller to sell him a pizza for, I think it was 2,000 Bitcoin. I don't remember the exact number, but
Yeah,
it
today
would
that's
be
like a $10 million pizza, right?
it would be millions, if not billions, today. So that was one of the famous transaction, and so Bitcoin has evolved. It's called digital gold because it's never really been hacked, but also it's quite simple. It's not smart in the way that it's not programmable. So then you have a second generation of blockchain that came out. So you mentioned Ethereum, Solana, etc. So these are blockchain that have built-in smart contracts. So it's intelligent money, essentially. So you can exchange value and program it. So to a certain extent, you could imagine that you have a legal contract which is built into the chain and that organizes payments in exchange for delivery of goods over the chain. So you could think of something called medical data.
Mhm.
All the hospitals, they want to share information about a particular condition
Mhm.
to come up with better outcome for the patients. But they cannot, or they will not, and they cannot share the information about the identity of the patient.
Mhm.
So, consensus learning could be an example of how this could be used to make progress by create a much larger research base, much larger training data set.
Mhm. Yeah, I believe this is a huge area that we need to change immediately. Like the legal terms around what parts of, say, for instance, medical information. There's a number of LLMs that have been employed. LLMs can read MRIs better than humans at this point in many ways. But in real world testing, we don't have enough data. So if you could obfuscate or federate away the proprietary information and then make all public record around conditions like heart conditions, for instance, then you'd be able to build out the world model for age and gender and other issues that would help that training data set. We need yesterday, in my opinion. So there's a huge opportunity there.
Yeah. Can you imagine that, large hospital chains, with many of them in the US, fairly large, so they can train AI to do diagnostic.
Mhm.
And then they could test their algos on other networks, other hospitals' data, and see, if their algo generates the same kind of diagnostic as the one from the other hospitals, and therefore, you could test them. That's called out of sample. So that would be a great use case to make those algo even better. Image recognition has reached, like, I don't know if you can call it superintelligence, because it's not necessarily better than the best of the humans
Right.
in terms of quartile or quantile, but it's been for a while now. It's been better than the average human. So when you look at the work of Ciccielli in image recognition, and how she came up with their system to do image recognition, it was close to 10 years ago now. At the beginning, the system was not as good as humans, but after a while, the system became better than the average human, and then became better and better. So, at some point, if your system is trained well enough, you can imagine that, a diagnostic by AI should be more accurate, more precise, more anticipatory than the one that can be done by a doctor. GPT is sort of state of the art. There is a guy called LeCun who has been promoting a new architecture. It's called JEP, adjunct embedding predictive architecture, which underlying principles are a bit different from GPTs. GPTs try to predict the next token.
Mhm.
Joint embedding works on what's called embedding. So it works on the vector that is underlying each one of those tokens. So that could be the next architecture, but it's still being debated in Lucan works at Meta, and Meta has made a lot of announcements recently, a lot of acquisitions, so to speak. It's not really acquisitions, but a lot of partnerships with a number of vendors like I think it was Cree AI. But they're still, it's a constantly evolving process. So now, what has come out since the beginning of this year in particular is agents. So agents are, what is an agent? Well, agent it's a piece of AI that has agency. That's why it's called agent. In other terms, that can make decisions for itself without being authorized or explicitly authorized by a human operator. One of the
It has a
consequences.
general autonomy, right? It has this.
Yeah, it's a form of autonomy, which, as you can imagine, is quite risky because we barely know how to validate LLMs, and when you come to agents and you have agents speaking to each other and making decisions without a human in the loop, it's creating some major. So those agents, they have to, they tend to be specialized by tasks, and they can communicate between themselves. And you have, multiple types of architecture of agents. You have, for example, actor critic, right? So an agent may be generating an answer, and another agent may be criticizing that answer and sending it back to the actor so that he can generate a better answer. You have agents that are orchestrator. So you have sort of a master agent with some specialized agents, and the master agent coordinates the action between all these different agents. Anyway, so you have several categories of agents. But because those agents have agency, they have a form of autonomy. They can move into the space of economic transaction. So an agent per se cannot have a bank account because they don't have a social security number, at least in the US. So as such, they don't hold a bank account, but they can have a wallet. And that wallet may be on a centralized exchange or a decentralized exchange. Or it can maybe outside any exchange, like a MetaMask, okay? So the point is, it's those agents can make financial transactions. And one of the major issues in making financial transaction is identifying who is your counterparty with a certain level of certainty. So, for example, if I do a wire transfer to your checking account, okay, let's say I'm going to wire $100 to you. Well, you're going to give me your checking account number, your ABA, etc. And I'm going to go to my checking account, and I'm going to do that wire, and you're going to receive the money tomorrow or the day after, or maybe today. But I know who you are. You know who I am. There is a reason for us to do this exchange. And so there is no uncertainty around that. If an agent has agency and they start to make payments to other agents, there are no humans involved. So how do you know that you're paying a legitimate agent? How do you know that's a correct level of price? And the blockchain is a good way to enable that authentication. So tokenization and the ability for blockchain to enable financial transaction in a zero trust environment, which is a characteristic of blockchain, is a space which is a sort of a natural space for agents to exchange economic value. So it's not the only one. The hyperscalers are coming up with solutions. You have startups that do agent authentication also. But the blockchain is a natural space for that. So, we may see the convergence of a form of AI and a form of blockchain that enables payment between agents to accomplish exchanges of services, goods, and value and payments.
Yeah, no, this is a really great tie back because LLMs have been accelerating digitizable activities, right? Like scans, PDF generations, generating RAG systems. So in finance, could you name just what are the top couple use cases where you've seen consistent implementation?
I mean, the thing that you see everywhere is information extraction. So
Mm-hmm.
you're talking about RAG. Okay. Now, a lot of financial institutions, they have
Is that
LLMs.
buy side? Or are you talking about like evaluation for investments?
It can
Those
be buy
kinds
side or sell side.
of.
So, yeah, it can be buy side or sell side. The thing is, what is the exposure of the AI to the end client? That's really the question. Okay. So is the AI used by a subject matter expert, which is able to make a judgment call on the answer it gets from the AI? Or is it used by somebody in the back office who may not be an expert on the topic, but is also not client facing? So the answer from that back office person may not be high risk for the financial institution, whether it's buy side or sell side. Then you have the front office. Okay. So if you talk about the buy side, for example, financial advisors, so they still are the one manipulating the AI, but they're client facing. But eventually, it's their judgment who comes out. It's not the AI talking directly to the end client. And then you have the ultimate stage, fourth stage, which is the client, the end client, which is not an expert, which is not an employee in the financial institution. It's just a client. And it interacts with institutions through the AI. So now the question is, how do you manage the risk of that kind of interaction? Because legal case show that the provider is liable for the answer. So, how do you make those systems safe enough that they provide a reliable answer, at least an answer that is as reliable as a very good human or the best human potentially.
Right. Let's double click on that. So, you map out when you're speaking, you talk about the model risk management framework. Take us through just at a high level. How are you, what model are you, what framework are you using there? And what have you seen successful in risk management with AI implementation?
Well, I can talk to finance because that's what I know. In finance, we have a framework which is called SR11-7. It was produced in 2011, so 14 years old. It was produced after the 2008 crisis. And in particular, after the collapse of Lehman and AIG. One of the problems there was, in particular with AIG, is that, as you know, AIG was rescued by the US taxpayer for the modest fee of, I think it was $80 billion. The team in London was managing their insurance portfolio at FP, at Financial Products, in a very confidential way. Nobody could take over the portfolio. So AIP was forced to keep the team on, and with US taxpayer money, enable that toxic portfolio to unwind and eventually, save AIG, at least save their clients from disaster. That's what triggered this regulation, SR11-7. It took another couple of years, and the Fed and the OCC came up with these rules that all the models should be documented, and they define the way it's documented. So there is what's called conceptual soundness, then there is outcome analysis, and then there is continuous oversight, or also known as ongoing monitoring. And for each one of them, the number of best practices that financial institutions, especially on the sell side, the one that are regulated by the Fed and the OCC, have to follow when they manage their what's called inventory of models.
Mm.
So that's really the starting point of the regulation in the financial industry, especially on the sell side. Now those standards are being applied to also the buy side. I mean, at least the large buy side institutions, all the BlackRocks, all the way to the smaller ones. They're trying to apply, or they're applying those standards because they feel it's a healthy way to protect against the risk of failure of those models. And this framework has been extended now to incorporate machine learning and now to incorporate large language models and GPTs. So there are other standards. NIST in particular, NIST, came up with a framework for managing AI and machine learning. So there is NIST, it's called the Risk Management Framework. Then they have one framework which is called AI 100. Then they have AI 600. And then you have private initiatives that, you have the EU AI Act.
Right. Yeah.
And then you have private initiatives like IBM, for example, came up with AI governance framework. And, the big, technology companies, they have their standards, and they try to manage the risk of those machine learning, large language models, AI in general, in the best possible way.
Yeah, agreed. NIST, EU leading the way. Although NIST doesn't deal with a lot of governance around regular users, right? It's a lot of attack vectors and things like that. So the question here, in your experience, what's the biggest blind spot that most financial firms have when it comes to AI governance?
I think the biggest blind spot is the end user expectation, as we call it in finance, first line, is way above and beyond what a good governance framework can deliver. So there is latent risk that is not identified. We talk about guardrails, but I can guarantee you that no system is 100% safe. The system can be jailbreaks. It can be
there's native hallucination, and there's a native error that gets compounded with AI agents. So I'm just wondering, in your clients, right, that you're speaking to now, how much is going on around that? Like, is anyone putting governance in place for those?
Yeah, everybody's doing it, but it's still work in progress. It's not. There is no definite final answer about how it should be done. So there are a number of metrics that you can look into. There's a number of processes. They are gates that you have to go through. So you can, try to frame the risk and limit the risk. It's not 100% safe unless you use it for applications that are which output is controlled by humans. So, for example, if you do code generation and you test every single line, and you have a human reviewing every single line, so then it's as good as a human can do because it's been tested by humans and it's been validated by them. But as soon as you enter the stochastic world, where the output is not entirely predictable and you cannot test all the cases, then you enter a certain zone of uncertainty. So for LLMs, the approach that is popular right now is to use RAG, retrieval augmented generation. And the idea behind the use of RAG is, the output of the LLM is potentially infinite. Right. But if you use RAG and you use it on a limited set of use cases, then you should be able to limit the number of occurrences and draw a certain level of certainty in the production of the output based on the subset of data that you are particularly interested in, which is typically internal data from institutions. So RAG is currently the SOTA, the state of the art in LLM validation.
Yeah, so setting up a retrieval augmented generator that's using the tokenization and compute power of like a cloud opus or yeah, what sort of models? And then I think about it as having this data pool, which includes multimodal and PDFs. So if I'm trying to create investment summaries, right, is a great use case, then I can use the previous language in all my own contracts as a data pool with the retrieval augmented generation algorithm. Are you seeing a lot of that? Have you built
Yeah,
a lot of those?
that's what people are doing at the moment, at least in finance, which is where I operate. In finance, things tend to be language based. Remember, LLM is large language model, right?
Mhm.
But you have VLM, visual language model, and you have multimodal language, which can, I was mentioning that at the beginning, can mix voice, video, and text. So you can imagine that you even mix native language. You know, I've seen videos, I don't know where it's true or not because I didn't experience it personally, but when LLMs talk to each other, if they realize they're talking to each other, they switch to an LLM language.
AI agents, we discussed earlier in some context. With AI agents, should AI agents be interacting with clients for financial firms today? What's your opinion on this?
Well, I think we can use agents for certain application. Um, I don't think we're at the point where we can exchange a meaningful or material value through agents without some form of very serious control because the risk is just too high. It doesn't mean that humans cannot make errors. There was this famous mistake that was done by, I think it was Citibank, who, they had this fat finger error. They wired hundreds of millions instead of millions.
Right. Yeah, I
And,
remember seeing that.
and then the recipient said, "Oh, well, too bad, I keep the money." And there was a lawsuit, and Citibank lost the lawsuit. And then not only they lost the lawsuit, but they were fined by the Fed, several $100 million, if I remember correctly. So my point is, human error is everywhere. Humans are not perfect. They can make what's called operational errors. It's called operational risk. Are agents safer, more reliable than humans? I think the jury's out. Especially when you have multiple agents communicating with each other.
Right. And compounding errors or hallucinations.
Yeah, it creates a form of intractability, which, where is the responsibility, if there's an error, if you have multiple agents and they belong to multiple legal entities. And so it creates a whole bunch of new.
You bring up a really interesting point because, having been in robotic process automation and then machine learning, and now we're in this era of generative AI, I've noticed that people tend to think that the technology needs to be perfect. So when I've done product analysis and sold to big companies and some big banks, they'll expect there to be a zero risk. And so I'm curious, do you run into teams using the same operational risk or human risk that you were talking about? Do they evaluate their generative AI systems with that same criteria, or are they trying to set the bar to a 0% error rate?
I don't know of any agentic system that does financial transactions in at least wholesale institutions.
Well, I guess in this case, it would be something more like chatbots that are deployed. So finance has been early, I would say, right, at adding LLMs to more of their workflows. And one place is customer service, for instance, right?
Their value is limited. So if you have a technical issue and you don't find the answer yourself, either through Googling or asking OpenAI or asking Gemini or Perplexity or whatever, Claude or one of the systems, it's unlikely that a human operator is going to be able to. I mean, the chatbot is probably not going to do it because they don't have the level of sophistication of a Gemini or an OpenAI.
So looking forward, what do you say, or what do you think the one capability, like name one capability that would convince you that we've crossed over into artificial general intelligence territory? What would that be?
There is none. We don't have AGI today.
Mm-hmm.
And so there is a lot of confusion by the leaders in that space, right? Because they get on the stage and they say, oh, we're going to have AGI in 3 months or 6 months or in 20 years, whatever. But they don't define AGI.
Mm-hmm.
We have artificial specialized or artificial super specialized intelligence.
Mm-hmm.
You know, if it's specialized, we already have it. If it's general, we don't have it. And we're unlikely to get it anytime soon. So I take all these answers with a grain of skepticism. Although I'm a big user of AI, I mean, I spend 1 or 2 hours every day working with AI. So AI is very good, for example, deep research, exploring a new topic that you know a little bit about, but you're not necessarily an expert, and you want information about it. So, doing deep research with OpenAI, with Gemini, with Perplexity, with Claude is a lot of fun because you get some feedback that contains information that you don't necessarily know about. So it's a way to broaden the scope of your knowledge. So that's why I like it, and I use it quite a bit. But it's a research tool. It's not an intelligence tool. It's not.
Right. Yeah.
It's sometimes it's hard to read. It's not necessarily well organized. It doesn't necessarily point to the key topics. So you have to do it in multiple systems. You have to use different prompts. Maybe you have to use meta prompting. Okay, you have to use an AI system to generate a prompt that is more efficient than the one you can generate yourself.
Right. Yeah.
It's meta prompting.
Yeah, right. Most of the image generators, right? Sora's been doing that forever, just converting what you're asking for into another, maybe even poorly designed interpretation of what it's looking for. Well, Frederic, thank you so much for joining us today. What would you like to say to listeners, or how can listeners engage with you? Is there anything you're looking for?
They can connect with me on LinkedIn if they have questions, if they want to have a conversation. That's the easiest way to reach me. Do mention that you listen to this video so I know where you come from if you reach out to me. Because sometimes I get invitation. I don't know why people reach out to me. So I have developed this habit of every time that I reach out to somebody on LinkedIn, I always send a message saying, oh, you said this, you wrote that, you spoke at that conference, whatever. And that's why I'm reaching out to you. So I know their angle. I know where they come from. It's a lot easier.
Well, and thank you so much. You've been really generous with your time with me, and you're a member of AI Circle and other organizations, and just appreciate your support.
You're very welcome. Thank you, Chris.
Yeah, and to our listeners, thank you. If you like and want more AI discussions, subscribe to UNAI on YouTube. Drop us a note on what you would like Tian or myself to discuss in emerging tech and emerging AI. We'll be back soon with Jennifer Horton, another AI Circle member. Frederic, I don't know if you've heard her speak.
Yeah,
from Microsoft.
Microsoft, yeah.
All right, keep exploring.
She's a very interesting character, so you gotta have a great time with her.
All right, take care now.
Take care. Bye-bye.